Hey, everybody. Thank you so much for joining us today. My name is John Bent. I'm the CORTX Community Director. We are super excited to have with us here today Johann Lombardi, the Chief Architect of the DAOS Object Store from Intel, and Nikita Danilov, the Chief Architects of the CORTX Object Store for Seagate. We're going to talk about the partnership between Intel and Seagate to deliver next-generation object stores for next-generation data centers. Johann, Nikita, do you all want to introduce yourselves? Johann.
Hey, John. Yeah, thanks for inviting me. I am Johann Lombardi. I am the lead DAOS architect, and I've been working on this project since 2012, and I'm very happy to be here today.
Hello, I'm Nikita Danilov, and I'm the chief architect of CORTX object store developed by Seagate. And I'm working on this project from its very beginning.
Thank you both. All right, well, so with that, before we talk about exactly, the motivation for why we need to marry these two object stores together and exactly how we're going to do that, let's start with talking a little bit just about CORTX itself. If you could take Nikita, please.
Yes, thank you, John. CORTX is a high-capacity next-generation object store developed by Seagate, and the entire product is called CORTX, and the underlying object store engine at the core is called Mult-Tier. CORTX was designed from the very beginning for extreme scalability with input from extreme computing community and HPC community. And it supports both vertical scalability, where you increase the power of individuals in your cluster by adding more memory, more CPU, more disks, and also by scaling horizontally by adding more and more nodes to the system. So the I/O path is also fully scalable. It allows you to grow the performance of the system with the number of nodes in the network. And one distinction feature of CORTX is that it's very flexible in its deployment schemas. If you look at the diagram, both client and server are called Mult-Tier instances, and this is because they are actually the same code. There is no structural difference between Mult-Tier client and Mult-Tier server. It's just that some instances have access to persistent storage, and because of this, they work as servers. And others just work with clients and provide various front-end interfaces like S3, PNFS, or POSIX clients. And you can also do extensions to CORTX, that is just add functionality to the system without modifying the core code and without impairing the scalability. And we will talk about this maybe later. And finally, it goes open source today.
That's awesome, Nikita. Thanks. So to summarize, CORTX is, I'm an architect myself. I know it pretty well. It's a new object store that we're announcing today. It's 100% open source. We're super excited. It's got a bunch of the features that you would expect from object store. And I think the one that Nikita mentioned, I think is most pertinent for this meeting here today is that it's uniquely optimized for the mass capacity storage devices from Seagate. We're shipping 20 terabyte drives today. We've got a view in a few years to be shipping 50 terabyte drives. We have a fundamental belief that the best way to enable the mass capacity devices is to have object stored software that is optimized for those devices and to open source it so that the whole world can see how to best enable those devices. And with that perspective in mind, Johann, if you can tell us please about DAOS.
Yeah, sure. So DAOS is a high performance next-gen storage object store, right? So it's really built from the ground up for non-volatile memory. Unlike CORTX, we have no support for disk drive typically. So the intent really is to provide a very high performance object store very close to the application. And we are able to leverage the latest storage technology like Intel Optane persistent memory to be able to store all the metadata and store bulk I/O on dedicated SSD that can be either 3D NAND or Optane SSD. DAOS has this ability to aggregate small I/Os into persistent memory and migrate them in bulk to the SSD. So only the application data effectively are stored on the SSD, and all the metadata are maintained into persistent memory. It really provides very high scalable, high bandwidth, and very low latency storage directly to the application. We have client-server model where on the client side is just a library that can be integrated with your favorite data model. Like we have support for POSIX, for object, for key value store over Fabric, HDA5, and many other middleware that can be directly integrated with application. And like CORTX, DAOS is open source, and we demonstrated the performance by publishing a result of the IO 500 benchmark.
That's awesome, John. Thanks. So I think, to summarize again what you said, this is another new object store. It's not so new. They've both been around, but it's one that's getting more attention. Both of them are getting more attention, obviously, with some of the announcements that we're making. And just as CORTX is optimized with the belief that you need new software to best enable mass capacity storage devices, DAOS is similarly tuned and optimized and designed, it sounds like, for Optane memory. Do you agree with that, John?
Yeah, definitely. Yeah. And actually, we had an interesting history together, right? Because I personally used to work with Nikita, where we were both at Cluster File System. And to some extent, CORTX and DAOS had very similar history, right? It initially started from a Lustre team that was eventually split between a team at WAM Cloud and Cluster Store, where at that same time a new distributed object store, CORTX on the Cluster Store side and DAOS on the WAM Cloud side, were started to be developed in parallel to the Lustre activities. And interestingly, over time, also the two object stores were developed in parallel. We ended up with a very similar situation where eventually the Lustre assets that was acquired by both Seagate and Intel were moved to a different company, and the core next-gen object store really stayed into the primary company. And so that's very, very interesting parallel across in the history for the two objects.
Oh, yeah, that's great. Yeah, so what you're saying is that there was a time Nikita and you were working together on Lustre, and Lustre split into two companies, Xyratex and WAM Cloud, and those companies were both acquired by large enterprise companies, Seagate and Intel, respectively. And at those parent companies, Lustre splintered off next generation object store, DAOS and CORTX, and you two ended up being the chief architects of those. Both of those companies then sold off the original Lustre assets, but retained those next generation object stores. And now we find ourselves bringing Nikita and Johann back together again to collaborate on next generation object stores. That's pretty awesome. Yeah, and I'll talk a little bit about what I sort of think the role of CORTX and DAOS is in next generation data centers. Right, so when we think about CORTX very much from like a Seagate perspective, we think about, okay, we've got the world's best mass capacity individual devices. We wrap those up inside our enclosures, our chassis, our drawers, which gives us, the lowest price per petabyte, highest capacity. But if we want to connect those with applications, with various frameworks like Spark and PyTorch and TensorFlow, we really need to connect them with something like S3, POSIX, potentially libCORTX or libDAOS, right? But certainly think initially from the CORTX perspective. And so we need to have some software, some distributed software to turn a collection of Seagate pods, Seagate, erasure block devices into a distributed data platform. And that's exactly what the CORTX software is. And it's designed for bandwidth workloads, capacity workloads, as well as metadata search. So, CORTX is all about enabling the world to save more and more of the precious data in the data sphere. And there's not a lot of value to saving the data sphere if you can't search the data sphere. If you want to store zettabytes and zettabytes of data, you need some ability to search it really quickly. And we're going to talk about that. So CORTX is great for bandwidth workloads, capacity workloads, metadata search. That's what it's designed for. But what you see in a lot of data centers is that, for the most part, a lot of the workloads, that's what they need. But sometimes you have workloads that need small IOPS, lots and lots of small IOPS. And, CORTX does okay if you've got every now and then a workload with a little bit of small IOPS. But if you've got large workloads with large demands of small IOPS, especially over a sustained period of time, quite frankly, CORTX is not going to be the best choice for you because CORTX is optimized for mass capacity devices. And those mass capacity devices are optimized for capacity and bandwidth, and they're not optimized for optics. So you're going to need a different storage media. And that's exactly where the Optane persistent memory from Intel comes in. And DAOS then is the object store. So just as CORTX is the object store optimized for the mass capacity devices, DAOS is the object store. And so now what you see is, well, these data centers are going to need some Optane. They're going to need lots of mass capacity devices. And they're going to need these two different object stores working together. So for the remainder of the talk, I think we're going to talk a little bit about that, how they work together. And maybe, Johann, if you could talk to us a little bit about just sort of that and how multi-tier is becoming the norm.
Yeah, thanks, John. So yeah, definitely due to historical acquisition, different use case, as you mentioned, when you are very IOPS driven versus bandwidth or metadata driven, at multi-tier is really the norm when you have to deal with different geography, with different retention requirement, different performance and capacity requirement across the tier. You really have to deal with very heterogeneous environment. And this is really becoming the norm, but unfortunately, there is really a need for a very efficient, smooth migration, integration across all the storage tier. So the requirement really for this multi-tier integration to be successful is that you can really move data very quickly, very fast data movement. You need to preserve the data integrity of the data set and also preserve all the historical metadata that you might have stored. It should be as transparent as possible for the end user and should be very flexible into the integration that it can have with a third-party policy engine. And that's really a must-have, in my opinion, when you develop when you work on next generation object store. And this is really what I really look forward to develop by integrating CORTX and DAOS together.
Yeah, thanks, Johann. But sometimes what happens when multi-tier becomes the norm, when the heterogeneity becomes the norm, like what you say, is that the migration of data between those tiers becomes pretty challenging. And what would you say is one of the biggest challenges or one of the biggest problems there?
So one problem we really have is that really POSIX is really the lowest common denominator, and this is not necessarily a good denominator, and this is where Nikita can probably give you more information on this.
Yeah, right. So indeed, moving large amounts of data between various tiers is not a trivial problem, far from it. And the interface that you use to access your storage is a very critical part of solution of this problem. POSIX is, of course, the best known, very widely used, everywhere present and everywhere implemented interface, but its age is showing, and it's not suitable for this task for multiple reasons. So first of all, the POSIX metadata schema is very rigid, and it is suitable for some tasks and some data sets, but it's in general is not very useful when you're trying to move arbitrary data set between one system and another system. And POSIX IO interface is very simple, and it doesn't allow you to work efficiently with the modern storage features like snapshots and holes. And you just duplicate data, potentially lead to a huge increase in data movement. It can be avoided. And also, it's not clear how you can move using POSIX between data sets that are not originally built with POSIX, like an S3 object store or HDF5 object. And finally, if you just use POSIX to access your large storage system, you probably will do a lot of scatter, gather, scatter IO. And this will limit your concurrency and data movement performance.
And so that makes a lot of sense then to me, Nikita. And so it sounds like, again, if we're thinking back about these weird parallel histories that you two have had, you worked on POSIX file systems for a long time. You started to come to understand that there's a lot of limitations in POSIX and there's a better way, and thus was born these next generation object stores, DAOS and CORTX. And now we're realizing, hey, we need both of them. We need the ability to move data back and forth. And does this bring us back to this sort of suboptimal world of POSIX, where even though we work so hard to get away from POSIX, now we're going to be stuck using POSIX to move the data back and forth between DAOS and CORTX, or do we have a better way?
Right. Yeah, I can tell you some bit of internal history here. So the history that led to creation of this interface that is now so similar between DAOS and CORTX is that we are trying to think how we can accommodate multiple front ends to the systems that would interoperate on the same data set. But I suppose that you want like a set of objects, that, well, some data sets that you access both through POSIX, NFS, and S3. And if you try to think how you can make various front ends interoperable, there is basically very little choice you have, and you will end up with this key value based attributes indexing subsystem that we eventually created in CORTX. And because the task of interoperation is in some sense similar to task of data movement. You don't actually move data, but you want to access data in a flexible manner. It's probably not very surprising that DAOS ended up having a very similar interface.
Yeah, I think that makes sense. So essentially, we can use then the similar interfaces that were independently designed, but motivated by similar problems to then move data between them in more optimal manners. That makes a lot of sense. And it looks like also this sort of next generation storage API that you both independently developed ended up being very, very similar. Do you want to go through some of the specific similarities, Nikita, that some of the audience might be surprised to discover are so close to being identical across these two independently developed?
Yes. Yeah, let's go through it. There was a list. So again, there was no like any kind of influence during development of those features, but we ended up having the same set of them. So we both have containers that allows your application to put data into multiple sets, and then you can efficiently iterate those sets. Built-in key value support that is fundamental both to CORTX and DAOS. In addition to object store, you can also store key value pairs. Native array object support is also there in both of systems. Concurrent key value insert, so scalability of key value interface is very important, and it's also important to support bulk operation, where you can insert large number of records in one operation. And then if you have multiple indexes and containers, then your ability to iterate through them efficiently, basically cluster-wide iteration through multiple indexes is important. And different object schema, like different erasure coding setups, replication, RAID 0, it's all supported in both CORTX and DAOS. And finally, distributed transactions are present in both systems, and they include transactions that involve operations both on objects and key value stores.
And so again, a bunch of these similarities in the API is what makes the tiering optimal in terms of minimizing the data movement, as well as easy to do and debug from an implementation perspective due to the similarities of the APIs?
Yes, basically, a key value store is a critical component that allows you to access attributes and understand which objects you want to move, which parts of the objects you want to move. But to be really useful, you need other services like containers, for example. Right? It's not enough to just use key value store because, for example, you don't want to migrate your entire cluster, your entire data set. You want to migrate some subset, and then how you identify the subset? Well, for example, by putting relevant objects into some form of container. But now you need container support to do this. Yeah, so you need some set of features for efficient data migration, and they're quite similar in both systems.
Excellent, thanks. Can you just bring us up to speed just a bit, Nikita, on the current status of this integration work?
Yeah, so as the first step, we can have a simple POSIX level data mover that's based on MPI. And then we will convert it to the native interfaces provided by the system. And finally, it should be modified. It should become a fully functional migration integration system that is transparent to the user and has flexible policy engine.
Yes, we typically have a data mover today in DAOS that is operating at the POSIX level, obviously, that is built over the Lawrence Livermore MPI file utils. And really the step 0 is just to do the movement at the POSIX level, right? Just to demonstrate the baseline functionality. That's really when with step 1 that things becoming interesting, where we can do movement totally bypassing POSIX and doing this movement at the baseline API. DAOS today is able to serialize a container into a set of POSIX file, but obviously when it is on POSIX, it is just a serialization of our KV API that obviously is not POSIX compliant at that point, so you really cannot access the container as is. So with the integration with CORTX, we will be able to move at the KV level and being able to effectively access the container when it is moved to CORTX. And last item, as mentioned by Nikita, is really providing more transparent migration, as I mentioned before, really to be able to move data transparently without the user being in charge of explicitly triggering the data movement. Right, the transparent migration is an important case.
Yeah, well, thank you so much for explaining that, Johann. That sounds great. And I just want to double check. DAOS is open source, CORTX is open source. So this integration project, is this happening in private, or is this happening 100% in the open source and the community can watch it and come and join in?
100% open source. Even the data mover is open source, so we welcome any contribution, and even if it's just to give it a try, everybody's welcome.
Well, that's great. So on the screen now, I'm showing both of the projects are hosted and developed in GitHub. You can find both CORTX and DAOS there. I've put up the URLs. And so we'll welcome the community to please come watch us develop this integration and participate as much as people are interested. We're really excited to be open source and to welcome the community. Looks like we've got some questions coming in. So the first one is, how is the DAOS performance since it's using Optane persistent memory? I suppose that'd be for you, Johann.
Yeah, so DAOS performance is obviously very good. We are doing very well with metadata rate and IOPS and also bandwidth. So we also published, as I mentioned before, some results for the IO 500 benchmark, and I encourage you to have a look there. You can really see that DAOS shine very well with unaligned IO and when you have very high metadata performance requirements.
That's great. One coming in for Nikita looks like. What built-in support for tiering? Oh, that's a good question. What built-in support for tiering does CORTX have, Nikita?
Right. So in CORTX, each object has an attribute called layout that basically specifies how the object is stored in the system. And the default layout is basically network rate with arbitrary erasure coordinates, things like that. There is another type of layout called composite layout that effectively allows you to group an object from a set of sub-objects. And this set can be dynamically changed, and the single mechanism allows you to implement a lot of interesting functionality like snapshots, partial uploads, and also a flexible tiering mechanism where you can keep part of the same object on different tiers. Like some frequency access blocks of the object can live in a fast tier, and the rest of the large object can be migrated to a slower tier. So that's a technological underpinning of tiering in CORTX IO stack.
That's great. Thanks, Nikita. I think we have time for one more question. Here's a good one to close with. So the question is, how do the development teams feel about open source? DAOS, I believe, has been open source since its inception, but I think CORTX started closed and then went open. Nikita, how's the development team in CORTX felt about that migration from being closed to being open?
With a lot of hope, right? So we hope that there will be contributions and there will be a community that will help us. And it's actually it requires a lot of work and discipline to prepare for this. Right? We need good documentation, we need good source code structure, we need good release procedure, and so on.
That makes a lot of sense. One of the things that I know from some of the ones that I've talked to, Nikita, is people are excited to be doing something that they consider to be altruistic, right? Working for a company that's willing to give away all of these secrets and to share the development with the world is something that a lot of them are excited about. And Johann, what about for you with DAOS? Because you all have been open source from the beginning. Was that the right decision? Does your development team do you wish that you could go back and undo that, or how's?
I spent my whole career working on open source projects, so for me this is just the de facto standard and the norm. So yeah, I really like open source and just writing community people we can try it out, report issues and make contribution. I think I don't regret it at all, and I'm a big open source proponent.
That's great. Well, thank you both so much for the time today. We're talking about the partnership between Intel and Seagate to develop next generation object storage, and we're really excited about this partnership. So thank you both for your time.
Thanks a lot. Bye-bye.
Thank you, John. Goodbye.
Goodbye, everybody.